Welcome to the second session of physics discussion. Last time we started with a few problems from the January 2023 paper. I think one question was left from that paper, which I will cover today, but I will cover it to the end of the class because that question and the last question of the April paper are of a very similar kind, so we can cover them together. Okay, so we can start with the April paper. And I hope that all of you have got a chance to go through the questions before coming to the lecture so that you are well prepared with your own approach. As far as possible, if you are able to solve each problem on your own, that is the best thing, right? Or even if not that, you have given it a sincere attempt. So you know that what are the variables involved, what are the approaches that can be tried, and maybe you are just missing one step. So going through the solution together with in the lecture will help you that way. So as far as possible, be prepared for every lecture, and this applies to even the chemistry and the mathematics sessions which are going to happen this week. Okay, so do your best to be prepared for that. uh, Along with that, what are other techniques which I mentioned last time, like just to share my screen for a minute. So we went through a couple of slides last time that where we discussed what are the ideas to be applied while solving a problem, that we have to convert the problem into equations, choose the right variables, consider the important formulae, solve the mathematics, and interpret the data back into the original problem. So I hope that you have also got a chance to practice these things for whatever questions you have solved from various sources. So we make it a habit of going through these steps for every question that you attempt. Okay, so that will become a natural part of how you are thinking about that. Along with that, also make sure that you have created some kind of revision material for yourself, like what I showed you last time, that I like to write all the formulae in a nice table fashion, so that at a quick reference I have all the information in front of me, so that I can quickly revise before the day of the exam. So make sure that you're practicing all of these good techniques, good study patterns. Okay? So that will greatly improve your chance of doing well at this exam, and in fact every exam that you're going to give from now on. Okay. So with that introduction out of the way, let me just directly jump to the paper. So this is the April 2023 paper, which we are going to start discussing. And I mean, you will see that almost, if you compare the questions side by side for the January paper from last week's lecture and this paper, the topics almost align perfectly. Like the first two questions are from kinematics equations, then you have density, and so it is pretty much the same syllabus is being tested, but with different questions. But I mean, there is no guarantee that, I mean, nobody is saying that that is how every paper will be. So you have to be prepared for any surprises that may come to you. But largely the topics covered will remain the same. So, your focus is to get the mastery on the topics. Don't try to, prepare for the paper. That don't try to prepare with the mindset that I will have one question on density, one question on electric charge. Any number of questions can come on any topic. So your task is to be prepared for all of that. Okay, so if we start with the first question, and this time I would like to give all of you an opportunity to attempt the problem from the very first one. So anybody who has solved the problem, question 11, please raise your hand. How did you solve it? Uh, can you briefly explain? That would be great. Okay, Athar, anybody else? Only Athar? So others, either two things, right? Either you did not get a chance to attempt the question, or you gave it your best attempt but could not complete the solution. So uh, depending on what is the situation, so that will change how you take the discussion, right? If you have given it an attempt, then you are better prepared to understand the solution. So that is what I'm emphasizing, that as far as possible, to try to come prepared for the question. So yes, Adar, I'll ask you to solve the question, but let me just quickly describe the question before we start to actually solve it. So, and as usual, we are going to apply all the good principles that we learned last time, that we would like to draw nice diagrams wherever possible. So, for example, in this case, what is given is that, so there is a building and an object is thrown from the top of the building, right? So it is initially thrown vertically up with some initial speed u, which we don't know, right? So the initial picture is like this. So we don't need to draw the building actually, because finally the object is going to fall to the ground. but just for reference, I've drawn it. So the initial speed is u. So this is the picture at the 0th second. Okay. Then uh, what have they given that after some time, what will happen? The trajectory of the object will reverse, right? So it will start to climb, and then after some time, it will start to fall. So what they are asked is what happens in the fifth second. So when we say the fifth second, it is the time between t equal to 4 and t is equal to 5, right? So at t is equal to 4, let us say the object is at some position s1. Okay. And when we write S1 as the displacement, again, going back to what we discussed last time, that choosing the right sign is very important. That how are we measuring the distances? Is this S1 above the building, below the building? So we will choose the convention that upwards is positive, downwards is negative. Okay. So like keeping this as the line of reference. So this is what we call this displacement. So if that object is below the building, S1 will be negative. If it is above the building, S1 will be positive. So automatically the sign will take care of the direction. And after that, t equal to 5, the object will fall even further. So let us say at this point, the displacement is S2. Okay, so this is the setup that we know, right? So Athar, you want to continue from here? What do we do next?
So actually, I did follow means very other approach. So
Okay,
actually, I have done in my foundation. I have given a formula distance in
mm-hmm.
nth second. I used that
Right,
formula directly.
right, okay. Yes, correct.
But that
So
formula was u
yes,
plus a into n minus half. So I got the answer directly.
yes, correct, correct. So what Athar is mentioning is exactly where we would like to go. That maybe everybody is not prepared with that formula, so we should try to derive it, right? So let us do that in this particular case. So basically, what we want to know is that how much is the displacement in the nth second. Okay, so displacement in the nth second is what we are interested to know. And again, what Atharv is giving you an example is that if you have this formula ready, then you don't have to derive it in the exam and you will save some time, right? So for those who have not derived this formula or not aware of this formula, you should make this a point to add in your revision material that what is the displacement in the nth second. Okay. So when we say displacement in the nth second, we are talking about a displacement from the time of n minus 1 to t is equal to n. So if I calculate the displacement at these two instances and I subtract it, I will get a displacement in the n second, right? So using the standard formula, which is ut plus half at square, right? So in general, if you apply this formula in these two cases, then the first displacement, so if I call it S1, is the displacement at the n minus 1 second. So that will be how much? U times n minus 1 plus half into A into n minus 1 square, right? And the displacement in the second moment, that is 1 second later, will be the same formula, except instead of n minus 1, you will have n, right? So these are the two displacements at n minus 1 and n respectively. So the difference between them will be this answer, right? So displacement in the n second will be equal to S2 minus S1, right? And so if you calculate that, what you are going to get is equal to un minus 1 plus half a n square minus. Okay, so I'm just subtracting the two equations. And so if you simplify that, you will see that some things get cancelled. And inside the bracket, what are you going to get? So here you will get n square minus. Okay. So again here you will see that n square and n square get cancelled. And so finally what you're going to get. Right. So sometimes it is noted delta. So displacement in the n second is given by this formula. U plus half a to n minus 1. Sarup, can you confirm this is the right formula?
Yes, sir. This is the
Okay.
right formula.
Yes. Okay. So, I mean, it took us a few seconds to derive this formula. So just imagine that if you have this formula ready, you are going to save 15 seconds, 30 seconds maybe, and directly apply this in the question. Okay. So now to apply this in the question, so we are saying that the change in the displacement is given by this formula, and we know that information, right? It is given that it is 35 meters. So what does that mean? That S2 is 35 meters below S1. So now we have to interpret this formula in our context, that what are the variables that we know. So first is how much is the acceleration, right? So A is the acceleration here. So that is the gravitational acceleration, which is G, right? So the value of G is 10 meters per second square. But again, remember the convention that we are always taking downward pointing vectors as negative. So because G is going to point downwards, we should take the acceleration as minus 10 meter per second square. That is the first thing to keep in mind. And what else? What about the displacement itself? That is also downwards, right? Because the object is traveling downwards, right? So the change is 35 meters in the negative direction. So therefore, delta S is also minus 35. So if I plug both of these values in my formula, right? So delta S is minus 35 and the acceleration is minus 10. Okay. And what else do I know? I know N also, right? N is 5, right? Because this is the fifth second we are talking about. So in this formula, everything else is known and u is the only unknown variable. So we should be able to substitute and complete the calculation, right? So let us just do that quickly. So I'm going to get minus 35 is equal to, so I just can keep u to one side and take everything to the other side, right? So I'm going to get u is plus 10 meter per second. Okay. And in this case, the kind of step three of interpreting this back in the original question is not that relevant. Only point is that the value, magnitude, and the sign you are getting is positive, which matches the picture, right? Because initially u is thrown in the upward direction. So we expect the value of u to be positive. So that is correctly matching here. That is the only thing to be confirmed. Okay, let me just check if the answer is correct. Yes, it is done. Okay, so I
Sir,
think this was a yes, go ahead.
what if in the scenario it comes as like minus 10, then what do we do?
If the question is correctly designed, it will come as plus 10 only. But if if you get an answer of minus 10, what that means is that the object was not thrown upwards, it was thrown downwards. So if the question is itself wrong, then I think you will get the credit of the question anyways. But
Okay.
most likely that is not going to happen.
Okay.
Okay. So in fact, if in case you get a negative answer, like suppose somebody gets a minus 8 meter per second, that is going to be an alert for you that maybe I've made some mistake. That always we will blame the paper the last. We will not start by saying that I got minus 8, so the question is wrong. Maybe I have made some mistake. Only once I've ruled out all the possibilities that my calculations are perfect, only then I can say that maybe the question itself is wrong. And in that case, then I don't have to worry that the paper setter will give the credit to all the students. Okay, but that rarely happens, and especially in physics, it is much more unlikely because, as you see, we always try to keep the calculation very simple, so people don't make calculation mistakes. Okay, so we can go to question two, question 12. Sorry, again, anybody who has attempted question 12, you can raise your hand. Okay. Only Atharva has solved the paper. Nobody else has solved the paper. Okay, Aditi also very good. Okay, so I'll just wait for 1 minute. You want to read the question? Okay, so again, we should start by drawing a good diagram, right? so that we know exactly how the objects are placed in various parts. So, so we have a horizontal surface on which an object is kept of mass 1 kg, right? And it is moving in the towards uh, a force of 1 Newton is applied in the horizontal direction. So let us say so here let us say the convention is positive to the right, negative to the left. So always draw this kind of legend in the corner, right? How whenever you have seen a map, it always has a northeast, west, south kind of legend. So like that, it is always useful that you indicate the direction clearly so that you don't make a mistake or you don't forget that which direction you are taking positive. So force of 1 Newton is applied on the object. Okay, and the force is applied for t seconds. So the initial picture, we can say that this is the picture at time t is equal to 0. Then for a while, what will happen? The object will keep accelerating and traveling to the right. So after some time t seconds, generally not using the same letter is recommended, but here I'm using t for both of it. It's okay. Then for additional t seconds, there is no force acting on the object. So what will happen that during this time period, the object is going to gather some velocity, right? So at this point, it will have some velocity u, let us say, okay? And so for the next t seconds, next how many seconds? Yeah, for additional t seconds. So now when the time is going to be 2t, so the clock will say 2t seconds. So for the next t seconds, the object has been continuously moving without acceleration, right? There is no force acting, so the velocity will not change. So in this part, the object is simply moving with a constant velocity, right? And finally, one more time, a new force is applied of 1 Newton in the opposite direction. So now we are going to decelerate the object. So now from this point onwards, the force is in the, so velocity is to the right, but the force is to the left. And again, the magnitude of the force is given as 1 Newton. So what will happen? The object will keep on decelerating. And finally, if you think about it, right, this picture, the first part, right, we can call this phase one, right? Phase one is when the object is accelerating with the force of 1 Newton, which lasts for t seconds. And the last phase, right? So if I call this middle phase as phase two, where there is no acceleration, and phase three is when the object decelerates back to, uh, so decelerates back. So if the same force is applied once in the right direction and once in the left direction, its effect will cancel out, right? So basically, if the object started at zero velocity, it will end at zero velocity also. Okay, do you agree that at the end of the third phase, again the velocity of the object will be zero? You can almost think of it like if I take a recording, like if you record the video of the first 3 seconds and you play it in reverse, that is what phase 3 is going to look like. So there's like a mirror kind of symmetry. So that is why during this phase, the object is going to decelerate back to velocity of zero. If you are not convinced, you can actually derive this also. You know the kinematics equation. So if you actually put in the initial velocity u and compute the final velocity, you are going to get the same answer. Okay, but this additional observation will help you to save some time. So now finally what is asked that the total distance traveled in all of this is given as 200 meters. Okay, so what is given is this total distance. So all the way from the start to the end, this whole distance is given as 200 meters. And from that, what we have to find out is the value of this t, right? So what is the value of t? Okay. So yeah, again, so with this explanation, again, I want to turn to those who raised your hand. Can you raise your hand again? Who solved this question? Athar, Aditi, right?
Yes.
So, Aditi, can you explain how we will approach the problem now?
Yes, sir. So I use S is equal to UT plus half AT square. And
Yes,
substituted where T will be 2T and A is 1. So
right,
by that we get 4T square is equal to 400. So T will be 10 seconds.
right. Okay, so we are just going to use the S is equal to UT plus half AT square, and in that, and we have to apply that formula separately for the three phases because in each case the force acting is different, so acceleration is also different, right? So if we have to do the calculation, we can do it the right margin itself. So let us say for the phase one, so firstly, how much is the acceleration equal to? It will be just the force upon the mass, right? So that is simply given in this case as 1 Newton and 1 kg. So it will be 1 meter per second square, right? So therefore, S, the displacement will be So ut is 0 because the initial velocity is 0. So it is simply going to be half into a into t square, right? So if I call this S1, so S1 is the displacement in the first phase, right? So that is the S1, how much the object has traveled in the first phase. Okay. Then what about S2? So how much distance the object has traveled in S2? How do we calculate that, Aditi? Aditi, can you explain how we calculate the displacement in the second phase?
Okay.
Because there is no acceleration there, right? It is just a constant velocity of u. So we just have to apply the formula distance equal to speed into time, right?
Yes.
So, so we can find velocity from first means the velocity
Right.
will be constant. So
Correct.
at means t second we can find velocity, and
Yes.
we can find distance by that velocity.
Yes, correct. So we know the velocity at the end of the phase one. Actually, these phases you can almost think like how a rocket launch happens, that it has to be done in stages, right? Stage one, then you boost the rocket for some time, then you switch off the engine, let the rocket continue with its momentum, again switch on a second engine. So it is like that only. So the displacement we got was half at square, where a is 1, so I'm just writing it as half t square, and the velocity, the u is equal to 80, right? Where again a is 1, so u is equal to t. Okay. So I know the velocity is u. So for the phase 2, how much is the distance? S2 will be simply speed into time, right? So it will be simply t square. Okay. And finally, for phase 3, now you have the option of again plugging the values in kinematics equation and deriving it. But based on what I observed earlier, right, the phase 1 and phase 3 are identical. It is just mirror image of each other. So I can just directly write S3 is equal to S1. Like how much time it took for the object to accelerate, the same time it is going to take to decelerate, and come to a complete stop. So this S3 is going to be equal to S1. Okay. So that will save me some time instead of calculating this again. So I can just write this is equal to half into t square again. So therefore the total displacement, right? The total displacement of all the three phases combined, which I know is 200 meters, right? That is given to me, which will be equal to S1 plus S2 plus S3. So that is half t square plus again half t square. So therefore the equation I'm getting is 200 is equal to 2 times t square. And so if you solve it, you're going to get t is equal to 10 seconds. So one very interesting thing, here I took t equal to 10 seconds, but technically speaking, t can also be minus 10, right? Even minus 10 is a valid solution of this equation. So why are we considering plus 10 seconds and not minus 10 seconds? And what does that minus 10 even mean? What do you mean by minus 10 seconds? Anybody is a fan of science fiction? What does minus 10 seconds mean? It means traveling backwards in time, right? So what are we saying actually? That minus 10 seconds is a very interesting point. We got our answer. So the answer is 10 seconds. We should be happy and we are done. But a close observer of the physics who is really interested in the physics, wants to become expert at physics, has to answer this question. What does minus 10 seconds mean? So the way to interpret that minus 10 is that t can also be minus 10. So in other words, if you solve the same problem, imagine that the object is traveling backwards in time, then also you are going to get the same answer. So just imagine that here the object started from position A and reached position B. But suppose the object starts at position B and everything happens in reverse. Then also the object has traveled 200 meters, right? So either direction you go, you are going to travel 200 meters. So that is what the minus 10 can mean. That is one interpretation. There can be multiple ways to think about this, but do give it a thought that don't just move on to the next question. Every time you get two roots like this, spend some time to understand what could that second root mean or second solution mean. Okay, that will make you a really good physics student. Okay, any other doubts in this question or how we solve this question or any alternate approach?
Sir, won't S3 be negative?
S3 is not negative because the movement is still in the right direction, right? So the object is still moving to the right. So as per our convention, it is going to be positive. When will S3 start to become negative? If you continue to apply the force for even longer, then what will happen? The object will go ahead and start to come back.
So okay, it is only applied for t seconds. Okay.
Yes, yes. We are exactly stopping at t seconds. So that is where it is not moving. Okay. So that was question 12. Then moving
Sir,
on. Yes, go ahead.
we can also solve by method of graph.
Yeah, graph method is also possible. So like basically you can think of this like a let us say on the x-axis you draw the time and on the y-axis you draw the displacement. So initially the object is starting here. So for t seconds, let us say that these markings are themselves at intervals of t, 2t and 3t. Then the object will first accelerate for some time, then it will remain at constant velocity and decelerate, right? So something like this you have in mind?
Yes.
Yeah, yeah, okay. Yeah, that is also fine. Finally, what we computed here, like if I make this marking, so this was S1, then this part was S2, and the final part was S3. So we are adding that the same thing. So yeah, I think it all depends on your style of learning. That some people like this visual representation of a graph, so you can do it that way. But I think calculations don't change that much as such.
Can you take up?
Okay.
Yes, thank you.
Okay. Okay, so let's move on to the next question. So question 13. This is about density, buoyancy, those kind of topics. So what is given this time is that there is a cube of some, so wooden cube means it is lighter than water. So it is floating in the water initially. So let me draw a diagram. So first the wooden cube is there in the water and then a metal cube of some other density and smaller in size. So the dimensions are given. So this is the wooden cube of size 40 cross 40 and on top of that a metal cube is placed of size 20 cross 20. Okay. And so what will happen is that the whole combination will right. So after the metal tube is placed, what will happen? The whole thing will start to sink, right? So in fact, I could not show the water level at first because I don't know where the water level is. But then what is the question asking that what is the height of the portion of the metal block which is above the water level? So what we expect to happen is that the whole wooden block will go underwater and some part of the metal block will also go underwater. So the finally the level of the water will come somewhere like this. Okay, so where some part of the metal block is underwater and the entire wooden block is underwater. And this is the position where the whole system is in equilibrium. And what we have to find out is what is the height of the portion that is above the water. So we have to find out how much is this distance which is above the water. Okay, so for calculation, actually, I feel that let us assume that this distance is x, right? The part below the water, let that be x centimeters. So then the answer we want is 20 minus x, okay? Because the part which is actually below the water will be more relevant for us because that is going to give us the buoyancy force and those things, right? So just to simplify the calculations, I'm making this assumption, okay? So now, if the whole system is in equilibrium, what we can say that the force of or buoyant force is equal to the gravity force or what is called the weight of the object, right? In magnitude. So again, if I have to do it properly, I have to show the direction that the gravitational force is downwards and the buoyant force is upwards, but they are going to cancel each other, and so we can ignore the sign for this moment. We are just going to consider the magnitude of them, the absolute value of these two forces. Okay, so this is what we know, that the buoyant force and the gravitational force are going to be equal. And then what are the expressions of these? So the gravitational force is simply the total mass of the system into g, right? And here the total mass will be the mass of the wooden block plus metal block, right? So this is the total mass. Okay, and on the left hand side, what is the force of the buoyancy equal to? It will be equal to the weight of the displaced liquid, right? Weight of the displaced liquid. Okay, and that itself can be written as mass of the displaced liquid into the density of the liquid, right? Sorry, into gravity. I forgot gravity. Into g. So this is the left hand side, this is the right hand side. So right away, do you see that the gravitational force is going to get eliminated from both sides? So we are just now going to compare the, sorry, I am making mistakes here. Yeah. So mass into the g is the weight, right? So now g will get eliminated. So therefore, what we are saying is that the mass of the displaced liquid has to equal to the total mass of wooden plus metal block, right? Okay, because the gravity simply eliminated. So now we just have to compute the left hand side and the right hand side, and that will give us the equation. So on the right hand side, I just need to calculate the total mass, and for that I have everything, right? I know the volume of both the cubes and the density of both the cubes, right? So the wooden cube is given of density 0.5 grams per cc, and the metal cube is given of 4.5 grams per cc. So let us compute the RHS first. So to find the mass of the wooden cube, I just have to take 40 cube, that is the size of the object, into 0.5, right? And the mass of the metal cube will be 20 cube into 4.5. So all of this is in grams, right? We are using the CGS system for this question. So the right hand side we know exactly. And now the left hand side, so I don't want the mass of, I am only interested in the mass of the part which is displaced by the solid, right? So if I'm highlighting that in blue color here, so this is the only part of the volume which I'm interested in. And so can I compute how much that volume is in terms of this X? So the whole wooden cube plus this, only the metal portion which is submerged inside the water. That will be the left hand side, correct? So therefore this can be written as, again, density of liquid into volume of the displaced liquid. Right? And I think the density is given to me. Density is given as 1 gram per cc. So this is simply 1 times. So now this volume part will be the volume of the wooden cube, which is 40 cube plus. So now can somebody tell me that how much is the volume of just the metal portion which is submerged? Like if I denote it by green color over here. So how much will be this volume?
Sir, 400 into h.
400 to h, right? Because if I draw that as a 3D object, right? Just temporarily, if I draw that as a 3D object, it is going to look something like this. So this is just the part which is below the water. So here the two sides are 20 and 20, right? The cross section of this is 20 and 20, and the height is the x centimeter which I assume. So the volume will be 20 into 20 into x, right? So which is 400x. Okay. So that's it. So now we know everything, and the only unknown variable in this equation is x, right? So if I equate this and this, what am I saying? That 40 cube plus 400x is equal to 40 cube into 0.5 plus 20 cube into 4.5. So if I am able to solve and get the value of x, that will be my answer, right? So like now if I take this 40 cube on the other side, it will become minus 40 cube, right? So 400x is equal to minus 40 cube plus 40 cube into, instead of 0.5, I can write it as half. So I can see that this minus 40 cube and this will cancel and become minus half, right? So if I take 40 cube common, so therefore x will be equal to, so I'm just going to divide everything by 400. So 40 into 40, 40 minus half. And by the way, I'm writing all the calculations here, so it may seem like this is a very lengthy question, but when you are solving this in the exam, you are supposed to do a lot of these simplification in your mind. Okay. So like for example, in the exam, what I expect you to do is, like in your mind, you have taken this 40 cube on the other side, it has cancelled with that 40 into 0.5, it has become minus 40 into 0.5. Then you divide by 400. So basically all of these steps you can do in your mind. Okay. So as far as possible, try to save your time that way. I mean, I will say actually every student has a choice, that somebody can be methodical like this to avoid any calculation mistakes, but then you are going to pay the price in terms of the time. So depending on how confident you are that you don't make calculation mistakes, you have to choose accordingly, right? So here I'm just for demonstration, I'm showing all the steps in lot of detail. Okay, so this is going to get cancelled. Okay, so x will be, so 160, so this will be minus 80 plus 90, which is 10, right? So I'm getting the x is 10 centimeters, right? That is what we were supposed to find out. So actually what we were supposed to find out was what is the part of the metal cube which is above the water. But luckily what happens here is that the height of the cube is 20 centimeters and exactly 10 is below. So therefore exactly 10 will be above. Okay, so basically exactly halfway of the metal cube is where the water level will finally come. Okay, I'll just wait for a minute. You want to copy down anything? And once more, in this, the first few steps, right, which we did here, they can be avoided in the exam if you have this final formula ready, that finally the mass of the displaced liquid is to be equal to mass of the actual object. So that relation, if it is available to you, you can finish the question paper. So one difference between this question and the last time question was, there we had only one object. So the entire object had uniform density. This time it was just to make a little bit tricky. We had two objects, right? The wooden and the metal with different densities. So the right hand side, we have to actually compute like volume by volume. We cannot directly say the total mass equal to total density into total volume. There is no such thing as total density if the two objects have different density. Okay. Any other questions about this question problem? Okay. If not, then we'll go to the next question. Question 14. Okay, so a question related to charges and forces on charges. So we had a similar question last time also, right? Where we had to apply the Coulomb's law, like when we know that if you know the values of the two charges and the distance between them, you can compute the electric force that is being exerted by one charge onto the other charge. So it is the same concept being applied here. So anybody who has already solved the question, can you raise your hand? Okay, Anirudh, you want to explain?
Yes, sir.
Okay. Just give me 1 minute. Let me just draw the diagram for everybody. So four charges are given at equal distances, and A is to the left, and I know the Q1. So first charge is plus Q1, minus Q1 over here, and plus Q2 at D. Okay. Okay, go ahead.
So I consider the charge at B as Q,
Okay.
and as the charges at A and C are plus Q1 and minus Q1, they attract each other.
Yes.
And the net force at B due to
Mhm.
ACD is 0. So
Yes.
F of AB plus F of BC should be equal to F of BD.
Yes,
And
correct.
if we consider the constant as K, we can solve it and we can get the value as 8.
Yes. Okay. Others, you have a similar idea that you basically compute the effect of every charge on B, right? What is the most important information given in the question is that the charge at B has net force 0. That the net force on that point at B because of all the other three charges is 0. So we just have to add up all the forces. So we are assuming that let us say the charge at B is plus Q, okay? Just to give some signs or some like directions to the forces. So if I say the force due to A, right? So will that be because they are both positive, right? So A will repel B, right? So the force due to A, if I denote an arrow like this, it will toward the right. What about the force due to C? Will it also be to the right? Because C is going to attract B. So A is going to repel B, so it is going to push to the right. C is going to attract B, so therefore it is also going to push to the right. And however, D is going to repel, and so D is going to repel to the left. So these are the three forces acting on B, and their sum total is 0, right? Total force on acting on B is 0. So if I just add up this FA, FC, FD, that should be 0. And one interesting thing you'll see is that the distances between these are not given, right? It is not given that how much distance is there between these charges. Because if you think about it, that term is going to cancel out anyways. So let us say for our calculations, we assume that some variable r, right? So some variable r we use to denote all of these distances. Yes, Aditi, you want to add something?
Sir, have you considered that the charge on B is positive?
It is a completely arbitrary choice because if I consider it to be positive, these are the arrows. Suppose somebody says that no, I would like to consider negative charge. What will happen? All the three arrows will change in direction, but the total will remain 0, right? So
Yes,
whether you consider positive or negative, your final equations don't change. So you are free to assume anything. Okay. So the distances between the charges also I'm going to let us say they are all r, and the Coulomb's constant, right? So that also is not given to us. So let us say that Coulomb's constant, we just say it is some unknown factor k, because that is also going to cancel. Because why are these things going to cancel? Because they are going to appear in all the three forces, right? And again, let us consider the convention that rightwards is positive, leftwards is negative. So FA, FC are positive, FD is negative, right? So let us start to write. So FA is going to be so the Coulomb's constant into the product of the two charges, right? Upon r square. Okay. Then what about FC? Okay, so I think here instead of writing the signs of the charges in the expression itself, let us leave that out because we already know that FA is positive, right? So I'm going to denote it that way only. So instead of writing the plus here every time, let me just write it as Coulomb's constant into the magnitude of the charges. So the first Q1 into Q upon R square. So this is FA. Then if you think about it, FC will have the same magnitude as FA because the charges are exactly the same, right? Only the sign has flipped. So FC will also be Q1 into Q upon R square. And FD will be, only FD will be negative, right? So FD will be minus of K into magnitude of the charges. So Q2 into Q. Now, but the distance is 2r. Keep that in mind. So the distance is twice as far. So the denominator will be 4r square, right? 2r bracket square. And what we are saying is that the total force, which is FA plus FC plus FD is 0, right? So if I just add up all of them, so I'm going to get K times Q1 into Q upon R square into 2, right? Because FA and FC are going to add up, minus K times Q2 into Q upon 4R square. This is 0. And so in this expression, you will see that so many things are going to get cancelled, right? K is going to get cancelled, small q is going to get cancelled. So interesting, right? That the value of this static charge at point B, that plus q is also does not matter. So let us say that charge becomes double in value, then all forces will become double in value, but the sum total will remain 0. So that is why these things don't matter. Okay, so just rearranging this, taking this to one side, I want to get K into Q2 into Q upon 4R square is equal to 2K into Q1 R square. And so straight away cancelling all of this, right? Cancelling Q, cancelling R square, cancelling K. I am simply going to get Q2 upon Q1 is equal to 2 upon 1. And I think that is what we had to find out, right? What is the ratio of Q2 upon Q1? Let me check the answer. Oh, the answer is 8. Oh, sorry, I made a mistake in the calculation. I forgot that there is a 4 here. So, see, I made a mistake. I was in a hurry to finish the problem and I forgot that this 4 term is there. So, this kind of mistake can be very costly in the objective paper, right? Where you got everything right. You understood all the concepts, but you missed one small term and you lose the marks. So, you have to be very careful about these kind of questions or this kind of paper in general. Okay. Okay, so, but I hope everybody has understood the approach that you can assume whatever variables are not given, right? The distance between the charges is not given, so we just called it R. Coulomb's constant was not given, so we just called it K. Because at the end, we know all of that is going to cancel because we are, you see why this is all going to cancel because all the three forces being considered are all electric forces. So all of them will have the same constants. Where it will not work is, some of the force is electric, some is a gravitational force. Then each expression is different, right? If imagine a different question where we are seeing the electric force plus gravity force is 0. Now it will be different because in the electric force, the Coulomb constant will come and the gravitational force G will come and they will not cancel. So if this kind of combined situation is there, then you need a different approach. But where it is all electricity or all gravity, then all the constants are going to vanish. Okay, so this is a common pattern which you are going to see in all these kind of questions. Okay, any doubts, or we want to move on to the next question? Okay, so then let us go to question 15.
Sir,
Yes.
sir, I don't understand how the force on B will, how the charge at B will be 0.
Charge at B, no, nobody is saying the charge at B is 0. The total force on at the point B. So there is some positive charge over here, which we are calling plus Q, and that charge will be attracted and repelled by the other three charges, right? So what the question is saying that total of all those three forces is 0.
Yes.
There is some charge at B. See, if there, let us say that there is no charge at B, let us say there is a neutron, right? Neutron has no charge. Then that will not be affected by electricity anyway, right? So then the remaining forces ACD will neither attract nor repel that. Only because there is a non-zero charge there, that is why the forces are acting,
Yes, sir.
right? Okay, so for question 15, anybody who has already solved it? So there are different ways of doing this question, but what I'm going to show you is the easiest way in terms of calculation. Finally, all the approaches have to do the same calculation, but if you want to save time, then instead of having 3, 4 variables, if you have only one variable, it will always be better, right? So we'll always try to reduce the number of variables we need to worry about. And for that, you just have to read the whole question from start to end before you start solving anything. Because if you understand what they're asking, what is the information given, what is the nature of that information, then we can suitably get rid of some variables. Like for example, the finally, if you let us read the question from the end to the start, which is unconventional way of doing it. Finally, they want us to calculate R2 upon R1, right? So we are only care about the ratio of those values. So if let us say I double the value of R1 and double the value of R2, the ratio does not change, right? So what that means, and even in the information given, if you see what is given, like in some combination that it takes T minutes to increase the temperature, and in some other combination it takes 10 T, which is 10 times the same temperature. So again, the information given is also in terms of ratios. So everything is coming down to ratios. And so you can exploit one fact that I can choose I can increase or decrease the value of R1 and R2 anyhow I like, as long as I don't change the ratio, right? So let us say R1 is 2 ohms and R2 is 4 ohms. I can double both of them I can say that it is 3 ohms and 6 ohms or something like that, right? So to make my life simple, why don't I just choose R1 as 1 ohm? Okay. So what I'm going to do is, okay, so see, initially the question is saying that the first values are 1 ohms and second values are 2 ohms. I'm saying let us divide both of them by R1. Okay, so I'm going to divide this by R1 and divide this by R1 also. So if I divide the numerator and denominator by the same quantity, I'm not changing the ratio, right? So the ratio R2 upon R1 will remain the same, but now this will become simply 1, right? And so now this second ratio will become R2 upon R1. Okay, and so let me call that lambda, okay, or some variable x, let us call it x. Okay, we always like to use the variable x. Okay, so instead of considering the original question where one value is R1 and other value is R2, I am going to consider the question when one value is 1 ohm and second value is x ohm. Okay, and I have to find the value of x. So straight away I have eliminated one variable out of my calculation. Okay, so now reread the whole question. Instead of thinking about R1 every time, we are going to replace it by 1 and we are going to replace R2 by x. Okay, so therefore now let us come to the main part of the question. What is saying is that when the heater is formed by connecting all of them in parallel. So first thing is that it is talking about resistances connected in parallel, and then the next part is when you connect them in series. So we can make two columns if you want. Like let us make these kind of columns that let us say on the left hand side we are talking about the parallel connection. And what are the three resistances? Two of 1 ohm and one of x ohm. So 1 x. These are the three given to us. And on the series side also again 1 ohm and x ohm. So the same three resistances are just connected in three different combinations. So if I want to draw it as a diagram, it is like 1 and x like this. And on the right hand side, they are in series like this. Okay. So first is what we call the equivalent resistance, right? So equivalent resistance. So do we know the formula for that? That in the left hand side, how much is that equivalent resistance going to be? So let me call it as RP. So RP for parallel, right? So in the parallel case, the equivalent resistance, what is the formula? Can somebody tell?
1 upon R1 plus 1 upon R2.
Correct. So the 1 upon RP will be equal to the sum of the reciprocals. Now here the reciprocal is simply 1 plus 1 upon 1 plus 1 upon 1 plus 1 upon x, right? So you see how conveniently choosing that 1 is going to make our calculation simple. And on the right hand side is simply the sum of them, right? 1 plus 1 plus x. So in the series case, that is going to be 2 plus x, and in the parallel case, it is going to be 2 plus 1 over x. Or if you want, you can rearrange this as, if I take the reciprocal of both sides, I am going to get Rp is equal to x upon 2x plus 1. Okay, so I found the resistance in both cases. Okay, next step. Then what is different between these two cases? In the parallel case, and again, see, they have given a lot of detail that they have given that there is some water of 10 liters and they have to increase the temperature by 20 degrees. What it matters is that how much work is to be done. So that if you see the quantity of the work in both cases is exactly the same. So we don't have to worry too much that how much, whether it was 10 liters or 10,000 liters does not matter. The point is that the same amount of work is being done in both cases, right? Or in other words, same amount of energy is being consumed in both cases. So that is the part we need to focus on, that the how much energy or work is being done. So now, do we know the formula for that? How much is the work done or energy? So work is equal to power into time, right? That how much power you are applying. So because power is the rate of the energy or rate of the work being done, right? So the work done is power into time, and that is same in both cases, right? The amount of work is identical. That heating that 10 liters of water for 20 degrees, that is identical. So I can just directly compare and say that the power in the left hand side case into the time taken in the left hand side case equal to power in the right hand side case into the time taken on the right hand side. So I'm just using the subscript P for parallel and S for series, right? So I can directly equate these two. I don't have to worry about what is the work done. Okay. And then do we know the formula for the power? How much is the power of a resistance? Do you know the formula for that?
V square by R.
Yes. So actually there are three formulas. Do you know all three formulae?
I
It
square
is
by R
I
and
square
VI.
R,
VI.
I into V and V square upon R. Correct? All three formulas are there. So in this case, which formula should we use and why? So this is where some general knowledge is useful. See, we are going to connect this heater to our power system, right? We are going to put the plug in our power socket. So the voltage coming from the power socket is the constant. So what matters is the current constant, is the voltage constant? In this case, the voltage is the constant, okay? Voltage is constant. Why? Because we have heard this, that in our home appliances, the power we get is like 220 volts, or in some cases it's 440 volts. So that voltage is the constant factor. So therefore, in all of these three formulae, we should use this one. Okay. Okay, I hope everybody is understanding this point, that which formula has to be used. Now that will change depending on the question. Here the voltage is constant, so I'm going to use this formula. In some other question, if the current is constant, you have to use the I square R formula. Okay, so if I just substitute here, so instead of power, I'm going to write again volt V square upon Rp into time taken. So the time taken is given to me, right? In the first case, it is t minutes, right? Is equal to, on the right hand side, it will be V square upon Rs into again 10 t seconds. What is given is that in the second case, it takes 10 t seconds. In the first case, it takes t seconds to. Okay. And again, here you see that the variables which are not given to us, they never told us how much is the value of the voltage, but it does not matter because it is going to cancel anyway, right? And even the t is going to cancel. So in fact, the only thing that mattered was the ratio, right? 1 is to 10, which I was saying from the start, that only the ratio is important, that the right hand side is going to take 10 times more effort to do the same amount of work. And now in this formula, we can substitute the Rp and Rs that we got from earlier, right? So I'm going to say 1 upon Rp is equal to 10 upon Rs. Or if I just rearrange this, Rs is 10 times Rp. And now in whole equation, X is the only unknown. So Rs was the series one, which was X plus 2, and Rp is X upon 2X plus 1. right? And so I just have to solve for x in this equation. So now this is just pure calculation. So if I take this to the other side, rearranging this, I get a quadratic. Okay. And so now here you can see the factorization as minus 4x and minus x. So this is one important point. When I say that you have to be good at mathematics, not just the theory, but the calculation. See, when you have a quadratic equation, you have three, four different ways to solve it, right? One is that you try to apply the b square minus 4ac formula. One is where you try to observe the root, the factors directly. You could try to complete the square and so on and so forth. So choosing the right approach to save time is again very important. Here I can quickly see the factors. So I want to waste time with the formula. But so that awareness is very important, that which method you use in which context. Okay. So let me just directly write the final factors. So therefore, I'm going to get two roots here, either x is half or x is 2. And out of which root should I choose? X is 2, right? Why? Because the question is itself saying that the R2 is greater than R1. So remember, what was X? X was our ratio, R2 upon R1. So if R2 is greater than R1, the numerator is greater than the denominator. So we want the value greater than 1. So therefore, X is 2 equal to answer. But interesting that if you choose X equal to half, that will also give you the exact same answer. Okay. And so the answer is, let me check the answer of question 15. It is 2. Correct. Okay. Okay, so let me again scan through the whole document so that you understand all the steps. I mean, when I explain it this way, it looks like a very long question, but if you break it step by step and plan in your mind that how you are going to do these things efficiently in the paper, it is not that long. Like very first thing that I did, that get rid of one variable from the outset. Instead of writing R1, R2, R1, R2 100 times and finally it is going to cancel, let me cancel it at the first step itself. So I have only the variables 1, 1 and x. Then I wrote the equivalent resistance of the series and the parallel connection. Then again important simplification, that I don't care about the actual work being done. I only care that the work done is equal. And then again substitute the correct formula for the power to get the value of x.
So how can you substitute the value of R2 by R1 for R2?
How did you substitute? See, finally, just imagine that if I double the value of R1 and double the value of R2, all in my entire equation, everything will get doubled. The equivalent resistance will be doubled, the series resistance will be doubled, everything will get doubled. And as a result, what will happen? The time taken, if the t instead of t and 2t, right? If let us say it is 5 minutes and 50 minutes, it will be maybe 10 minutes and 100 minutes, but the ratio does not change, right? So I am free to change the value of R1 and R2 as long as I don't change the ratio between them. So if I double one, I should double the other one. So in that way, I can just keep reducing the value of R1 down, down until it becomes equal to 1. So that is what I'm doing here. I'm just reducing the value. Like if you take a concrete example, if R1 is 3 ohms and R2 is 6 ohms, isn't it the same as 1 ohm and 2 ohms? I'm just eliminating one common factor out of my all calculation. If you still have a doubt, you can try to solve this question once more without making this assumption. That solve in terms of R1 and R2, but you will get the same answer. Okay, so that will convince you that really this method works. Okay. So I'm just sharing some ways to save time for you. It is not compulsory. Okay, if this is clear, can we go to the next question? So actually question 16 is you remember last time we did one question about mirrors where it was all about geometry. We had an equilateral triangle and all those things. Even this question is like that. If you, for those who have solved it, it is just geometry. Anybody has solved the question already? Okay, Anjum has solved it. So do you agree that it is just geometry, right?
Yes.
I mean, the only physics that you use is that what everybody knows, that angle of incidence
Angle of
equal to
reflection.
angle of reflection. Nothing else we really require. Okay, so let us start to solve that question. So AB and BC are the two mirrors given, and B. So basically, there is a ray going from P to Q, Q to R, R to S. That is how the ray is traveling. And every time it hits a mirror, we have to apply that formula, that angle of incidence equal to angle of reflection. So in this diagram, if I mark those angles, right? So this angle, the red dot we have shown here, which is equal to this other dot because of the physics part. And because of the geometry part, you know, alternate angles are vertex opposite angles. So therefore, this is also equal to this dot, right? So angle AQP will be equal to BQR and also equal to angle BQT. And same thing will happen at vertex R also. Like here, if I denote it by some different symbol, let us say, so this tick mark, right? These two are going to be equal, where the ray is hitting the mirror. And again, because of vertex opposite angles, the same angle is going to be here. So therefore, angle uh, CRS is equal to angle BRT, BRQ, and BRT. Okay, so I hope everybody is following this. So as a result, and what is given to us is this angle is given very conveniently, right? So if you want, one way to do it is if you call this x, x, and y, y, and if you know that the sum of the angles of a triangle is 180 degrees, right? So therefore, this angle, this unknown angle, right, angle T will be simply 180 degrees minus 2x and 2y, right? And in this, if I take 2 common, it is 180 minus 2 times x plus y. And do we know the value of x plus y? From the inner triangle, right? In triangle BQR, I can get x plus y is equal to 180 minus the third angle, 132. So I know exactly how much x plus y is. So I can just substitute it here. 48, right? So my angle T is 84 degrees. Anybody has a different way of getting avoiding these calculations? Anybody can quickly find the answer of T? X, X, Y, Y. What is this? Same. Is there any special? Yes?
Angle bisector.
Angle bisect. So what is there some special name for the point B? What is this point B?
The in center of
In center, right?
90 plus a by 2.
Yes, exactly. So this QB is the angle bisector of this angle, and RB is the angle bisector of the other angle. So therefore, what that makes is B is the in center. Sorry. So you see, you should be alert for these possibilities. Everybody has studied in center in school, but suddenly, unexpectedly, the in center is going to help us here of triangle TQR. And so again, if somebody knows the incenter, you can also know that the formula of the angle formed, the QBR, is 90 plus uh, the other angle by 2. So if whatever is this angle, half of that plus 90 degrees is the middle angle. So if somebody knows this, they can skip even one or two more steps, because now we can direct it at 132 is equal to 90 plus this t by 2. And so if you simplify this, you are going to get t is equal to 84 directly. Okay, so again, be on the alert for these kind of possibilities. And I hope everybody agrees this was actually just a geometry question. The angles of incidence and reflection is the only physics that we used as such. Okay, so I think we can move to the next question very quickly. Question 17. Okay, so once more question 17 on lenses and convex lens. Last time I had given you one formula to quickly calculate, at least for this kind of convex lens case where object is on one side, image is on the other side. So in that case, this formula is very easy to apply. So that is why I given it to you last time. So well, just to recap for those who don't remember, so what I had given you was that if the object is here, the image is here, right? So we measure the distances from the lens and we are just taking the magnitude, not the sign. So if I call this the DI, DO is the distance of the object and DI is the distance of the image, right? So I said that 1 upon DO plus 1 upon DI is equal to 1 upon F, where F is the focal length, right? So I hope everybody remembers this formula from last time. But one interesting addition to that is that, so this is our distances from the lens. But if you have seen the ray diagrams, right? Always there is one ray which is passing through the center of the lens like this. And as a result, what happens is that you get similar triangles. Do you observe that because of this 90-degree and this one angle in the middle being equal, I'm going to get two similar triangles. So the triangle on the left hand side and the triangle on the right hand side are similar. And if they are similar, then all the sides are in the same ratio, right? So if the horizontal side DO and DI are in some ratio, can't I say that the same ratio is applicable on this side also? So if I call this SO and SI, right? So DO is the distance of the object and DI is the distance of the image. Then SO and SI refer to the size of the object and the size of the image. And all these four will be in what we call proportion, right? So the ratio of them will be exactly equal. Okay, and this is sometimes very useful because you may be given the information in terms of the size, but you can convert that into distance and vice versa. Okay, and it will be useful in this question also, because if you go back to the question, the information given is in terms of the size of the object. So the very first sentence, that image of the object through the convex lens is real and half the size. And and in the second case, the image is real and of the same size. And then calculate the focal length of the lens. Okay. So now we have to think that how we will convert this information into variables. Like what are the variables I would like to assume? So let us draw the diagram of the first case. So in the first case, the length is given, uh, and the what is given is the image is half the size. So if image is half the size, based on this relation, can you agree that the distance of the image from the lens is also half of the object? In other words, if the object is at some distance, uh, like if I call the distance of the image as x, right? So this is the distance of the image. The distance of the object is going to be 2x. And why? Because the size itself is in that ratio. If the size is half, the distance will also be half. Okay. So we are just assuming that this 2x and x is the distances initially. And at this point, the image is getting formed correctly. So therefore, in this particular configuration, the length equation can be written. So I can write 1 upon 2x was 1 upon x equal to 1 upon f, where f is the focal length of the lens, and that is unknown. So this f is what we need to find out. So this is that first diagram. And now in the second diagram, what is going to happen? When the object is moved towards the lens by 10 centimeters, okay? So now I'm going to move the object, sorry, towards the lens, okay? So now the object is going to go to some new location. Okay. So the distance that the object has moved is 10 centimeters. So therefore, can you say what is the new distance from the lens now? It will be 2x minus 10, correct? Because the object has moved closer by 10 centimeters. And now in this case, what they are saying is that the image is real and of the same size of the object. So now you see important, the size of the object is also same as the image. So if the object and image are of the same size, the distance from the lens also has to be of the same size. So this distance, which was originally x, now the image may have moved to a different location. So we don't know where the image is, but what is guaranteed is that this distance and this distance are equal. Why? Again, because the size is the same. Okay, so keep this in mind that the ratio of the size and the ratio of the distance, this is very useful idea to solve lots of questions. And so once again, can I write the length equation? So I'm going to get 1 upon 2x minus 10 plus 1 upon 2x minus 10 is equal to the same focal length 1 upon f. And so I just need to solve these equations to find the value of f. So it is like two equations, two unknown kind of situation, right? So we just have to solve it. So let us just rearrange it a little bit. So the first equation can be written as, if I take the LCM on the left hand side, it will be 3 upon 2x is equal to 1 upon f. And second equation, because it is just 2x, 2 upon this is equal to 1 upon f. Okay, and I want to eliminate x out of this, right? So okay, if I rearrange the first one, keeping x to one side, I'm going to get x equal to 3f by 2. So which means wherever x is going to be there, I can replace it by 3f by 2. And so I can eliminate x from my equation entirely. So therefore, now this will become, so let me just cross multiply it first. So 2 into f is equal to 2x minus 10, which is equal to 3f minus 10, right? Here I am substituting the value of x from here. So 3f by 2 is x, which is the same as saying 2x is equal to 3f. That is why I can make this substitution. And so therefore I get the value of f is 10. So you see, once you get the equations, the solving part can also be done efficiently, but that is not the challenging part. The challenging part is figuring out this configuration, that the information given in terms of size has to be converted into the distance from the lens, because the lens equation only operates on the distance from the lens. So keep this in mind, keep this lens equation. And so these similar triangles, pay special attention to these similar triangles, because of which this formula is coming. Okay, I'll just pause for a minute if you want to copy anything. So let us move to the next question. Question 18. So again, as I said that you solved a very similar question last time. Only difference if you observe is that last time we had ice turning into water. This time we have water turning into steam. But many other things are kind of similar. That there is one object which is at a very high temperature, this block of metal, and it is going to keep reducing in temperature. And during that process, the water is going to see. So first understand in your like before even starting the calculation that what is happening in the whole system, like intuitively that the block of metal is going to keep cooling down. During that time, the water is going to keep rising in temperature until all the water has reached 100 degrees, right? Until that happens, the water is not going to start becoming steam. Once all the water has become 100 degrees, then the latent heat of vaporization will kick in and that will start converting the water into steam. And again, see, there are two, three possibilities here. One is that let us say the original block was not hot enough that the whole water will not reach 100 degrees also. That is one case. Another extreme case is that the block is so hot that all the water becomes steam. And the middle case is where only some of the water becomes steam, not all the water becomes steam. So all these three are possible. But here the question is giving the clear hint that which of the three cases is relevant here, because it is saying calculate the mass of the steam present at the end. See, if none of the water becomes steam, then the mass is going to be 0. Or if all the water becomes steam, then the mass of the steam is going to be 950 gram. But none of them are the answer. Something in between is supposed to be the answer. That is the hint that the question is giving us. So we should use that hint to simplify our approach, right? But again, in general, there is no guarantee. Like if you actually take a block of metal and water, any of these three can be possible, right? So let us start to draw the diagram. So the block of metal is at 600 degrees Celsius, and water. So metal is here, and water is here at 40 degrees Celsius. And we also know the specific heat of both of them and the quantity also. Oh, sorry, not 600, 1500. What is 600 grams? Sorry, 600 grams and 950 grams. And the specific heat capacity is given 0.1 calories per gram. And here it is 1 gram, 1 calorie per gram. Okay, so same as what we had done last time, that we can draw an intermediate picture where let us say that there is a point where all the water has reached 100 degrees, but it has not started to become steam yet. In that process, the metal will also cool down to some extent. We don't know how much, but the metal temperature will also come down. But instead of calculating this intermediate stage, which we are not interested, we are interested in the final configuration, right? Afterwards, after some time, what will happen is that so initially there was 950 grams of water, but after the conversion starts, let us say there is X grams of steam at 100 degrees. So when the water becomes steam, the temperature does not rise. So X grams is steam and remaining 950 minus X gram is still water, right? And so they are both at 100 degrees and the metal has also cooled down to 100. So now when you say the system is at equilibrium, everything is at the same temperature, right? So now here the metal is also at 100 degrees of water, 600 grams. So all the three, metal, steam and water, all of them are at 100 degrees. And in this process, what is the most important principle? That again, they have given this, every time you see this sentence, that insulated container is used, which means that no energy leaves the system, no energy enters the system. So therefore, total heat lost by the metal, right? The total heat lost over here has to be exactly equal to the total heat gained by the system, right? So heat lost has to be exactly equal to the heat gained. So to be specific, heat lost by the metal has to be equal to heat gained by water plus steam. So now it is just we have to fill the details, that which of these we can calculate, which are unknown, and solve for the unknown quantity. So left hand side, do we know exactly how much heat the metal is going to lose? We know it, right? Because we know everything. We know the total weight, the mass of the metal, we know the temperature, everything. So left hand side is simply going to be the quantity of the metal into the change in the temperature. So the how much is the change in the temperature? It is 1500 minus 100 degrees, right? Into the specific heat capacity, which is 0.1 calorie per gram degree Celsius. So this is the heat that the metal has lost and should be equal to the heat gained by the water. So now this has two components, right? Because the stage one, in the stage one, when the water was simply getting heated to 100 degrees. So how much will be the heat gained during that period? It is simply the weight of the water into the change in the temperature into the specific heat capacity, which is 1 calorie per gram degree Celsius. So this is how much heat was required to convert the water to 100 degrees. Plus now only the part which has become steam is going to absorb the latent heat, right? So here when we are saying that x grams of steam has emerged, so which means that there is x grams of steam, and we are given this latent heat of vaporization as 540 calories per gram. Okay, so x into 540 calories per gram. So this is the total heat gained by the water plus steam. And so in this, you can see that x is the only unknown variable. So we should be able to solve for it directly. Okay, so let us go ahead with the calculation. I hope that this time the numbers are slightly larger. So you have to have some faith that everything is going to cancel and you're going to get a nice integer answer. You just have to have faith that you are going to do the right calculation. So if I take this to the right side, whether is there anything going to cancel out of everything? I think that everything is divisible by 6. I think at least 60. In fact, I see 60 is one common factor. So let us get rid of 60 because 6 9 are 54. Yes. Okay. So okay. Now it looks much more manageable. It is not that crazy. So therefore 9x is equal to, so x is 50. Okay, so therefore 50 grams of steam has basically been produced. Answer is 50. Let me check the answer box. 50. Okay, good. Okay, so understood the process, that how we are breaking the problem down into and focusing on the important point. See, the heat lost equal to heat gain. This is the main principle. That is what the whole question is relying upon. Rest is just calculation. And of course, carefully that when you calculate the RHS, split the water increase as the first term and the latent heat as the second term. Okay. One interesting point I observed about this question, even in the previous batch when I did this question, right? It is a very curious thing. Look at this. Latent heat of vaporization of water. What does that mean? That how much energy it takes to take 1 gram of water and make it into 1 gram of steam. That is 540 calories. That is a very large amount of heat, if you think about it. 540 calories. Uh, if I just go back to the previous paper, right, where they had given the latent heat of fusion of ice, it is only 80 calories per gram. So converting ice into water doesn't take that much energy, and this takes almost like how much? 5 times, six or 7 times more energy to convert the same water into ice, same water into steam. Sorry. So you see, if in that case, if you remember what had happened at the end, all the ice became water, and after that, the temperature kept climbing. And so finally, the answer you got in that question was what? 10 degrees. So that cobalt block, just think about it, cobalt block was just at 400 degrees Celsius. And even that much heat difference was enough to convert all the ice into water and still continue increasing the temperature. Compared to that, this time the block also larger in size? See, everything is larger. The block was 225 gram. The block is now 600 gram, and it is at a very large temperature, 1.5 K degrees Celsius. I think maybe I don't know temperature of the sun, some part of the sun maybe like that, or the core of the earth maybe. And even that much heat is not enough to convert all the water into steam. So just imagine that how much energy is required. And I don't know, have you observed this in your home in kitchen? If you remove an ice cube from the fridge, just minutes it takes for the ice cube to become water. But if you are boiling water in a vessel, it takes a lot of time to reach the boiling point. So clearly there is some interesting difference there. Okay, but anyway, we can continue with the next question. Question 19.
Sir,
Yes.
sir, I am getting problems to solve these types of questions.
Oh, you are talking about question 18 or question 19?
18.
18. Okay, but did you understand the basic idea that I am just comparing the heat change in both objects, like how much the metal is going to cool down, how much the water is going to heat up, and I just have to equate the two, right? So where do you think you are getting stuck exactly? You should know all the formulae. That is the first thing. Do you know how much is the specific heat capacity? What is the relation between the change in the temperature and change in the heat absorbed or heat emitted? So that relation is given by the specific heat equation. So that you should know. And then the latent heat equation for converting solid into liquid and liquid into gas. So those two equations you should know. So first step is making sure you know all that formulae. Next step is making sure you know all the physics concepts. So the physics concept is that heat loss equal to heat gain. And once you know both of these things, then the last step is just the mathematics, the solving for the unknown variable. So try to break every question down into these three steps. Then it will become look easy to you. Okay, just imagine that you suppose you are in the exam and you get this kind of question. Just imagine that if I were talking about that, how will I explain it to you? Become your own teacher, okay? How will I break the problem down into smaller parts and then focus on one part at a time? Don't try to solve the whole problem in one go. Try to solve one part at a time and then you will get it. Okay. Apart from that, and apart from giving a lot of practice material, there is no other solution. There is no other magic formula. You just have to keep practicing and keep practicing with uh, conscious attention. Don't just solve problems because somebody is giving them to you. Solve them with the deliberate focus that I want to become better at solving problems. Okay, question 19. Again, it's very similar to the question we did last time, right? We had masses traveling. And what was the principle we used in that question, if you remember last time?
Momentum.
Momentum, right? And you see how everything is nicely given to like drive your thought towards the momentum idea. Like object A is given, its mass is given, velocity is given. So what is the only thing you know? If you know mass and velocity, you multiply them. Okay, so you get momentum. Question point B also mass and speed is given, so you get know the momentum. And the third object mass is given, speed is not given, so that is the unknown part. Okay, so actually you can solve this question in your mind completely. Do you see that in principle you know exactly what is happening, that initially the system has some momentum At the end, the system has a different momentum, but or rather it cannot have different momentum because of law of conservation. The initial and final momentum have to be the same. And so if I equate that, I should get the answer. That is all that should be happening in this question. Okay, so let us try to solve it that way. So if I have to draw the diagram for this, the point mass A is given of some, what is given? The mass is given, the speed is given, right? Let us say it is traveling to the right. Then the mass of B is given and speed is also given. And it was given in the question that B is behind A, so I am drawing it that way only. 20 kg and 4 meter. So you see the same characteristic as the previous question. We are not given at what time the system starts to move, how much is the distance between B and A. Like B and A can collide with each other in 1 second or 1 day or 1 year, does not matter. Okay. Finally, at some point they are going to collide. That is all that we care about. And point C is coming towards them from the opposite side. So point C is traveling like this, and we know the mass, but we don't know the speed. So this is the initial picture, and final picture is all three collide at the same point, at the same instant. So at some point, all of them are going to overlap. And when they do, the speed is zero. The mass is going to be, how much, sorry. Actually, mass does not matter, but just for completion. Total mass is 60 kg and speed is 0 meters. So the initial momentum of the system has to equal to the final momentum. And actually the final momentum is zero because the whole system has come to a complete stop. So which means the initial momentum is also zero. And it may be surprising that objects are moving, so how is the momentum zero? Obviously that is because we are taking the signs into consideration, right? The two objects on turning to the right have to be given positive sign. So if I write rho is equal to momentum of A, which is 10 into 1, plus momentum of B, which is 20 into 4, plus momentum of C, which will be 30 into minus U. Right? Why minus U? Because it is pointing towards the left. So you have two options. Either you can make the sign as part of U itself, then you have to write 30 U, and then you'll get a negative value for U. Alternately, you can pull the minus sign outside like this and let U just represent the magnitude. So the question you have to answer is, does U represent the magnitude or magnitude plus sign? Okay. Choose one of the two. Don't get confused that half the time you use the magnitude, half the time you use the magnitude plus sign, then you'll create a lot of confusion. So choose any one strategy and use it uniformly. In particular, when you yourself don't know whether the sign is positive or negative, you don't know whether C is turning to the right or the left, then you have to use this option only. Then you have to use magnitude plus sign, because then the sign will give you that answer, that if you get the quantity as positive, it means the object was traveling to the right. But in this case, where the diagram is clear, you know exactly that C is traveling to the left. So then it is okay to take the magnitude. But then you have to take the sign outside like this. Okay, so make sure to choose the strategy consciously. Don't just do something random. Then you will get the wrong answer. Okay, so therefore I'm just getting an equation. And so I know 30 U is 90 and U is 3. And what have they asked? They have asked the velocity of U. So therefore U is 3 meter per second. So you see how the calculation part was really small and simple. Overall only I will say this is a very simple question. Okay. See, these kind of questions where you are only applying one step at a time are okay at this level. This entrance test is going to test only these things. Finally, what you have to prepare yourself is for the JEE exam, where this question will be only one sub part of a much larger question. So you have to combine 4 or 5 such smaller questions to solve one JEE problem. So that is what you have to get prepared for. Okay, so you have to become very efficient at this small calculation. Only then you can combine them and solve a difficult question. Okay. So even those of you who are confident and getting these problems, don't get overconfident. This is just the first step. Okay. Okay, so this was question 19. Then last question, question 20. Actually, you know what? I'm going to skip question 20 for now. Let me finish the other remaining question first. If we get time, we'll come back to question 20, or else what I'll do, I've written the solution of 20 as a nice PDF. I'll just send the PDF on the WhatsApp group. Okay, you can look at that PDF. Because honestly, the question 20 is more about just calculation. The main idea is just applying the S equal to ut plus half at t square again and again. So just applying that displacement formula again and again. See, because if you read the question, it is about some relay race. So team A has two players, A1 and A2. So A1 moves, then A2 moves. So similarly, B1 moves and B2 moves. So you just have to calculate lots of small distances and add them together. Okay, so it is just tedious in that way. So therefore, I prefer to skip question 20 and focus on the other question. Okay, so the other question means from the previous paper, the question 20 which we did not solve last time. So let us solve that question first. Okay, so I'll just wait for a minute. You want to read the question? Okay, so looks like many things are happening in this question, that the car A is moving, it is accelerating, decelerating, and constantly it is changing its acceleration, deceleration. Car B also has some complicated pattern, it is accelerating, decelerating, and finally at some point they will both meet. That is what we have to find out. Okay. So again, like many other questions, there are two ways to do this problem. One is that you individually calculate the trajectory of car A, individually trajectory of car B, and wherever they meet, that is what will give you the equation to be solved. But what I want to show is a slightly different and faster way of solving the same question, and it makes the concept, uses the concept of relative motion. So this is a very important idea of relative motion. What is the meaning of relative motion? See, if you are stationary and some object is traveling, let us say that you are stationary and some object is traveling towards you at 20 meter per second. So you will see that it is traveling towards you at 20 meter per second because you are yourself standing on the ground. But suppose you are yourself in another object, like suppose you are inside a car which is also traveling towards that other object. So let us say that object is approaching you at 20 and you are moving ahead at the rate of 10. So now from your perspective, what will it appear that the other object is moving, approaching you at even faster velocity, right? Like you can imagine that you will collide even faster if you are on the collision course. So in this picture, what is the apparent velocity? So you can use the word apparent velocity. Like what does the object or what does velocity appear to be? Okay, or more formally, the word uses relative velocity. That what is the velocity of the other object relative to you? So what is the answer of this? Can anybody tell? How much will the
30
relative
meter
velocity?
per second.
30, right? It will
30
just
meter.
add. So if both of you are approaching towards each other, the velocity is going to add. And if you are going away from each other, the velocity will subtract, right? In the same picture, if instead of going towards, you are actually chasing away from them. Now it will appear as if that object is approaching you at 10 meter per second. And so on and so forth. Like you can make 3, 4 cases. Like there could be one case where you are faster, so you are at 20 and other object is at 10, then it will appear that the other object is moving backwards at a velocity of 10, and so on and so forth. So like 3-4 such diagrams you can draw. Okay, but the main concept is relative velocity. Similarly, we can also apply this concept for acceleration. So just as your relative velocity, you can also talk about relative acceleration, because the same thing will happen there also. Suppose now you are not only traveling towards, but you are accelerating at 10 meter per second square, and that object is also accelerating towards you at 20 meter per second square. So now what will appear is that as if that object is accelerating towards you at plus 30. So from your perspective, it will appear as if that object is accelerating at plus 30 meter per second square, and you are stationary. And similarly, other cases can be worked out. So similar to relative velocity, you can also have relative acceleration. So if we use this idea, the question that we are trying to solve can be simplified to a great extent. Because what is the question saying? The car A, and one very important thing, that when, what is the pattern of car A if you observe, that it accelerates for 5 seconds, decelerates for 5 seconds. So the cycle of car A lasts for 10 seconds, out of which first 5 is acceleration, next 5 is deceleration. If you see car B also has the same time, the value of the acceleration is different, but the time is exactly synchronized, right? Car B is also going to accelerate for 5 seconds and decelerate for 5 seconds. So in the diagram, if I look at it like this, initially car A is accelerating for what is the distance? It is 1 meter, right? So car A is going to accelerate at 1 meter per second square. Car B is also accelerating for 2 meter per second square. So this picture is going to last for 5 seconds. After 5 seconds, car A is going to start decelerating and car B is also going to start decelerating. Right? So this picture is going to last for another 5 seconds. And so after that, after this like 10-second cycle, both car A and car B have completed one round of their cycle, right? So therefore, we are going to look at each of them separately. Like if I call this phase 1 and phase 2, right? So in phase 1, what is happening? Both cars are approaching each other at so therefore the relative acceleration. So what is the relative acceleration of car B with respect to car A? This is with respect to. Okay. So in other words, for somebody sitting inside car A, what will it appear as if that car B is accelerating at plus 3 meter per second. Okay, so this is what is going to happen in phase 1. So under this situation, can we calculate how much the distance between them is going to change? See, initial velocity is 0, right? Initial velocity is 0 in both cases. Velocity is 0 here also, velocity is 0 here also. So if we apply the formula s equal to ut plus half at square, where the initial velocity is 0. Initially, it appears car A will see that car B is also stationary, so initial velocity is 0. And so therefore, the displacement is going to be half into 3 into and I should say minus 3, because it looks like it is approaching me, right? Into 5 seconds, so 5 square, right? So therefore, it is going to be 25, 75, right? So in the first phase, the distance between the two cars is going to reduce by 75 meters. Okay. What about phase 2? Actually, if you think about it, phase 1 and phase 2 are like mirror images once more, because well, I think the arrow of this should be reversed, because now this time the car has picked up some velocity, car B has picked up some velocity, but now they are both going to decelerate. Right? So if they are decelerating, if they accelerated for 5 seconds and picked up the velocity, and the same amount of time they're going to decelerate also at the same rate, isn't it going to come to a stop once more? So again, the velocity will be zero. Like if you want to draw it like a diagram, it will be look something like this. The car starts, picks up velocity, again it comes to a stop. And similarly, car B starts, it has some velocity, uh, and it comes to a stop. And so this loop of acceleration, deceleration coming to a stop will keep on repeating. And whatever change of distance was there here, the same distance is going to change here also. Same distance will change here, the same distance is going to change here also. It is like if you think about it, if you would have a ball in your hand, if you throw it up and for 3 seconds it is traveling up, then it comes to a halt. Next 3 seconds it is going to travel down and come back into your hand. The distance it traveled during the up time and the down time is the same, right? Only the sign has reversed. Initially it was velocity was upwards, now the velocity is downwards. So in the same way, here also initially the acceleration was forward, then the acceleration is backward. The distance is not going to change. Okay. So this I am giving you a way of seeing this quickly and saving time in the exam. If you are not convinced, you can write the equation, do the calculation, and you are going to get the same result. Okay. But that is the homework for you. Here I am giving you the shortcut that you can directly say that the phase 2 also has the same displacement. Right? How much your distance reduced between them in the phase 1, same distance is reduced in the phase 2 also. So therefore, after one complete cycle, right? Cycle of acceleration and deceleration, which lasts for 10 seconds, right? What is the net result of that? The distance between the cars has reduced by the 75 by 2 plus 75 by 2, which is 75 meters. And so now the question is how many such cycles will be occurring after which the cars will meet. And so that if the question has given the initial distance as 300 meters. So like one cycle of 10 seconds reduces the distance by 75 meters. So to reduce the distance by 300 meters, we will require 4 such cycles or 40 seconds. So the answer is 40. That after 40 seconds, the two cars are going to meet. Okay, let me just check the answer. Question 20. Yes, 40. Okay. So understand that this is to some extent I'll say this is a challenging question because there are lots of physics. Like you can do this question with calculation also, but if you know the physics concept, it will make your calculation that much easier. So two or three important concepts that we use here. First is the idea of relative motion, relative velocity, relative acceleration, so that we analyze everything from the point of view of car A. Otherwise, what would have to do? You have to calculate this same formula S equal to ut plus half a t square separately for car A, separately for car B, and then add them together. But instead of that, by looking at only from car A's point of view, I have to apply this equation once. So that was the first simplification. Second simplification was that understanding that phase 1 and phase 2 are symmetric. That whatever happened in phase 1, the reverse is going to happen in phase 2. So you don't have to calculate this again. So we got the same answer. And finally, it's just that putting them together and like unitary method of some kind, that how many times the 75-meter cycle has to repeat. Okay, so I'll just wait for 1 minute. You want to copy anything? Have any doubts about this relative velocity, relative acceleration? You can clarify them. But we have all had this experience in real life, so it should not be that surprising. When you're traveling in a train, you all have experienced this phenomenon, right? Your train is going in the forward direction. On the side track, the other train is coming in the reverse direction. It seems to travel so much faster. Is it really traveling that much faster? No, it is just because of the relative motion that it is appearing that that train is like some bullet train. But actually, you are both traveling at some moderate velocity only. Yes, Shreyas.
So can you please show question number 15 solution?
Question 15.
Solution.
Question 15. Okay, what was that question? this water heater, the resistances?
Yes, sir.
Oh, just a minute. I'll just show it in 1 minute. Let anybody copy this one. Should be also here. I'm just zooming out so that you can see everything. So again, if you want to just quickly walk through the idea. So first thing we did was a simplification that instead of having R1 and R2, we just replaced that with a single variable X. So that I'm just talking about the ratio of the two resistances. See, finally, what matters is the ratio of the two resistances. The absolute value does not matter. And then we apply the standard formula of resistance in series and parallel to get the RFP and RS. Then we equated the work, the quantity of the work is the same, so we can say work is equal to power into time. So you can equate those two directly and then just applying the formula, substituting the value, you get the value of X. Yes, Anvi?
So, in earlier, I had asked you the x that you substitute as like x is R2 upon R1, right? So how can you substitute that in one in like 1 comma 1 comma like R1 comma R1 comma R2 is given like the three resistors. So how can you substitute R2 by R1 for R2?
So I'm substituting the value of that resistance. So the numerical value of that ratio, right? Like here I give the example that let us say R1 is 3 ohms and R2 is 6 ohms. So the ratio which is 6 upon 3 which is 2 ohms. So I'm saying that the third resistance is 2 ohms. So instead of originally it would be 3 ohm, 3 ohm and 6 ohm, right? Instead of I'm just considering 1 ohm, 1 ohm and 2 ohm. So this was the original what was given and this is what I'm actually using. But I hope you agree that if I have reduced everything by the same ratio, then the final ratio will also remain consistent. Like, how do I explain this? See, let us say that you have two bulbs, okay? And I'm saying that one bulb is twice the power of the other bulb, okay? I don't tell you the value, that what is the value, but I just say that first bulb is twice the power of the other bulb. And then I ask you that how many photons are released by the second bulb compared to the first bulb. So without knowing the value of the resistance, we know that if the power is twice, it is going to emit two times energy, two times photons. So I can freely say that let the first bulb be of 1 watt and so the second bulb is of 2 watts and I'll use that to do all my calculations. And at the end, I will get that same ratio. So I'm doing something very similar here that I'm just saying let the first resistance be 1 ohm.
No,
And
but
let,
like so the example that you use now, like 3, 3 and 6.
yeah,
If you calculate the net resistance, it will be 5 by 6.
yes,
But if you use it for 1, 1 and 2, it will be 5 by 2.
yes. But the what matters is the ratio. Does the ratio between RP and RS change? Like you can make two columns, okay? So column one, you do the calculation for 336, and column two, you do the calculation for 112. In both cases, you find the resistance of parallel and series connection, and check the ratio between those two values. Because see, finally, in the calculation, isn't the ratio the only thing that matters?
Right. I got it.
Yes. Any other doubts? Yes, Tanmay?
Just to confirm, the x is the value of like we derived the x as the value of the second resistor, which is also in ratio R2 upon R1.
Yes.
Okay.
I mean, if I assume that the first resistance is of 1 ohm, so therefore I could say that the second resistance is of X ohm, which turned out to be 2. And so I know that the ratio of my two resistances is 2 is to 1. And so that will go to be true for the original values also. Whatever R1 and R2 were assumed, I don't know the values, but I know the ratio is the same.
Yes. Okay.
Okay. Okay, I can understand when you have difficulty to understand how can I make this simplification. So if you don't want to make this simplification, you can solve the whole question one more time where you have written 1 ohm, right? Instead of that, you will have to write R1, R1, R2, R2. The whole calculation will have R1, R2, R1, R2 scattered everywhere. And finally, you are going to get the same answer. Okay, so just for your काय म्हणतात तसल्लीसाठी तुमच्या confirmation साठी you do that calculation. But I hope that you're following this technique because if you apply these small shortcuts, it will save your time, make you more efficient, and that will give you a competitive edge. If you do the same thing that everybody else does, then how you expect to outperform them? So you have to be a little bit more smart and efficient in this way. Okay, but anyway, we are out of time. That's all I wanted to share from the physics side of things. Anything else that anybody wants to add before we close for the day?
So Thursday we will meet for chemistry, and on the lines of how we discussed last paper, I would also want you to already take a look at the paper of April 2023. So we will be able to go into little deeper theory aspects if I spend lesser time in just explaining the question. If most of you all are okay with that question, then we can look at the theory around it. And as we discussed last time, that surrounding every question, you have to look into the theory and take it as a learning opportunity, revision opportunity. So the lesser the time we spend on the question in particular, we will be able to touch upon more topics, subtopics, and maybe some quick hints you will get, which will help you to excel at the exam. Okay? Right.
Okay, thank you. There's just one question in chat that what should be your main objective in these remaining days? So from my side, because the suggestion I would give is that the time is very less, right? So if there is any topic which you have never even started to study, you won't have the time to understand it and start applying it directly. That will be very difficult. Instead of that, focus on your strengths. That which topics you are very confident about. Make sure you don't miss even one question of that topic. So focus on your strengths. Focus on applying what you know, that you should not miss even one problem from the theory that you know. Okay, so practice those kinds of problems. Make sure you know all the formulae correctly. Don't make mistakes in that, like not remembering the formulae. So these are basic things that if you do well, I think you have a very good chance of cracking the exam. Okay.
And remember that our scores are expected to be 50%. So that is a clear hint that you can go wrong in 50% questions. So as
Right.
Prashant sir is saying that don't divert yourselves to your weaker topics. Instead, strengthen your strong topics more and more. And then after doing that, whatever time spares in the exam, you will look at, and as Sunil sir told on Saturday, you will first solve five questions of each section, the best 5 of yours, and then you will go to, from the next 5, choose the better ones now. So then if you're not sure that your 5 questions are going to be correct, then 6, 6, 6, 7, 7, 7, 8, 8, 8, that way. So you need to score 50% in each section. That is very important. So accordingly, you have to divide your time and first ensure 50% marks in each section. And then wherever you are more doubtful, you can solve more questions to be on the safer side. So you can practice the practice papers in the same fashion now without looking into the solutions. Are you able to solve the questions? See the time you're taking to solve the questions. Are you able to fit yourselves in the given time? Etc. etc. So that should be your look. Okay.
Yes, right. And again, that the strategy which Sunil sir said, the 555 is very important. You may have the feeling that how will the order of questions make any difference? It is the same questions, but it will make a lot of difference on another level because when you solve the questions you know how to solve, it will improve your confidence. So you will be more calmer, you will be more organized. So there are a lot of benefits of choosing the right order and managing your time. Okay, so try all these things. Yeah.
Right.
Okay.
Okay. So we meet on Thursday,
Sure.
7 o'clock. Yeah.
Okay. Thank you. Bye.
Bye.
Yes, sir. Bye, sir.